In our last video, we had a look at the foundations of trigonometry. And if you missed it, I encourage you to go and have a look. Make sure those foundations are in place because you need to build on a solid foundation. We looked at right angle triangles. We were first introduced to these in grade 10. We saw that there are angles that we work with, and then in relation to those angles, we deal with opposite, adjacent, and hypotenuse. And that's where sine, cos, and tan came from. And it's very important that you know these ratios. And then we popped that onto the Cartesian plane, and we saw sine, cos, and tan can again be expressed, but this time in terms of x, y, and r, the radius length. And then once it's on the Cartesian plane, there are 4 quadrants, and that's where the cast rule came in. On the Cartesian plane, we look at the cast rule, and we learn that we can reduce any angle so that it fits here into quadrant 1, a nice acute angle. Okay, and the standard way that we address angles on the Cartesian plane is by referring to the x-axis. So in quadrant 2, we work with 180 minus. In quadrant 3, 180 plus, because that's where the x-axis is. In quadrant 4, 360 minus. Okay, and that helps us to determine whether or not something would be positive or negative when we reduce it. And then on rare occasions, we work with the y-axis, but remember that that links specifically to co-functions. So that means sine becomes cos and cos becomes sine. So that's the time when we use 90 plus for the second quadrant or 90 minus for the first quadrant. Then we also learned about special angles and where they fit in, and you can either use this method, which I call the fan method, or you can remember the special angle triangles, but we need to know these because we could be asked to solve questions without the use of a calculator, and that's where we deal with angles of 0, 30, 45, 60, and 90. In grade 10, we were introduced to 2 fundamental identities. Tan theta is equal to sine over cos, and sine squared theta plus cos squared theta is equal to 1. And now that we're in grade 12, we are ready to build on these identities. If you've looked at any matric past papers, you'll see they come with a formula sheet. And on that formula sheet, we are given these formulae. So formula for compound angles and for double angles. And in this video, we are going to focus on compound angles. So what you should notice straight away is that if you have sine of angle A plus angle B, and those are not like terms, as you can see, that definitely does not equal sine of A plus sine of B. So be very, very careful there. And that's why we have these formulae, because it's not about the distributive law in this instance. It's a whole new approach. Okay, and so if I get that, sine A plus B, then I head over to my formula sheet and I see, I'm going to replace that with sine of whatever angle A is, multiplied by cos of whatever angle B is, added to cos of angle A, sine of angle B. And just something that helps me to remember is that with the sine compound angle, then the sine stays the same. So it's plus there, it's plus there. If it's a minus there, it's a minus there. And then with the cos, the sign changes. Okay, so cos, you've also got cos, cos, and then sine, sine. So they're slightly different, but the good news is they are on your formula sheets. Let's see exactly how we would use these. Okay, so the first thing we're going to do is have a look at how to expand compound angles. So I immediately notice these are compound angles. Cos of x plus 35. Now remember what we said. It doesn't mean we can distribute. We can't say cos x plus cos 35. We need to go to those formulae on the formula sheet. So let's take a look at which one is relevant to this question here. Cos x plus 35. So it's one of the coses, and it's the cos with the addition. So that says that I can expand that to cos x, cos 35, minus sine x, sine 35. Nothing too complicated or stressful here. So we're just going to apply that formula exactly as it is. So in the place of angle A, we've got x, and in the place of angle B, we've got 35. Cos, cos, the sign is different in the cos formula, and then sine, sine. So that's it expanded. Now let's have a look what's going to happen with the next one. So sine of 30 minus x. So we find our sine formula with the subtraction. In the place of a, we've got 30. In the place of b, we've got theta. So sine of 30 minus theta is going to be sine 30 degrees multiplied by cos theta. Sine stays the same, negative. Cos 30 degrees multiplied by sine theta. And then, because this is a special angle, we can most certainly substitute that part in. So here we've got some special angle formulae, or the little diagram that's going to help us to figure that out. And let's see. Sine of 30. So sine, we know, is y over r, and cos of 30 is x over r. And then we move to the diagram, we find that 30-degree line, and then we can substitute in. So y is 1, r is 2. So this is now going to become a half instead of sine 30. Cos theta minus, and then we've got cos of 30 there. So back to that 30-degree line. Cos is x, root 3 over r, 2. So root 3 over 2 sine theta, and that will be the final answer there of the expansion. Okay, now this occurs quite frequently, is that we are asked to simplify something to a single term. So here we've got cos x, cos 3x, sine 3x, and we need to simplify that. Okay, what we need to get good at doing is recognizing, this looks like some form of one of our compound angles. Okay, so let's get that formula sheet out, and now we're going to have a look. Which one of our formulas is cos plus sine sine? Having a look, here it is, right at the bottom, cos plus sine sine. So that's the cos a minus b. So nice and simple here. We've got cos a is now our x, right? Let's write there a, and b is 3x. A and b. Okay, so we've got x minus 3x. This is a great question, because now look what happens. Cos minus 2x. And what do we do if we are sitting with a negative angle? We need to add 360 degrees. So we're going to say cos of 360 degrees minus 2x. And now we can use our cast rule to reduce that, because they want just a single term. Okay, now remember, this cast rule is not given to us. We actually need to know these things, but I've popped it in here just for reference. So in the 360 minus quadrant, that's here quadrant 4, cos is positive. So we can then reduce that, and we can say, thank you, the 360 degrees told us which quadrant to go to. We don't need it anymore. We can now say this is equal to cos 2x as a final answer there. All right, let's have a look at that other one. Sine 20 cos 2 alpha plus cos 20 sine 2 alpha. So we've got sine cos, cos sine, and we want to figure out where that fits in. So here's sine cos, cos sine, and we want a plus, which is the first formula on this formula sheet. So then A is 20 degrees, B is 2 alpha. So let's write that then as sine of 20 degrees plus 2 alpha. Okay, and there's nothing more that we can do here, because it's not one that fits nicely on the Cartesian plane like the previous one. It's not a negative angle. We don't need to worry about that. So we can just say that is our final answer. That is as simplified as this one is going to be for now. Okay, let's see if we can do these ones. Determine without using a calculator. So our brains go, they probably want us to do special angles here. Cos 50, cos 10 minus sine 50, sine 10. So straight away we're going, this looks like one of those compound angle formulae. Let's head to the formula sheet. Right, so we've got cos, sine, sine, and a minus. It's this one here, cos A plus B, or in other words, cos 50 plus 10. So let's rewrite that. Cos 50 plus 10. Now those are like terms, 50 and 10. They're both in degrees. So that then we can write as cos of 60 degrees, which is one of our special angles. Okay, now special angles are not on the formula sheet, so be careful. We can refer to the diagram, but you need to know how to draw that for yourself when you sit in your exam. Right, so here we've got some special angles to look at. Let's see. Cos, from our knowledge of sine, cos, and tan, cos is x over r. So we go to the 60 degree line, and we say the x coordinate there is 1, the r value is 2. So that can then be rewritten without using a calculator as 1 over 2. Okay, let's tackle this next one. So we've got sine 30, cos 15, cos 30, sine 15. So we need to look for sine cos, cos sine, and a plus in between. So sine cos, cos sine, but we need the plus between. So it's that first one there. That's going to be the sine of a plus b. In our case, a is 30 degrees, b is 15 degrees. Okay, we've got like terms again. So sine of 45, and then that is a special angle. Sine is y over r. So we head over here to our 45 degree line. Y is root of 2, r is 2. So sine of 45, root 2 over 2. Right, now let's put our brains to the test with one last example. Cos 70, cos 40, plus sine 70, cos 130. Okay, so the first thing, 70, 40, 70, not 40. Okay, but this is a big angle. So let's use our cast rule and reduce it to something smaller. So 130 degrees fits somewhere here. It's bigger than 90, smaller than 180. So we can rewrite that as 180 minus something. Everything else is fine, so we're going to leave it where it is. So cos 70 times cos 40 plus sine 70 times cos, and this is now going to become 180 minus, and 180 minus 50 will give me that 130 that I need there. Okay, so now to reduce it, this part can stay, plus sine 70 multiplied by cos in the second quadrant. Look at this, sine is positive, so cos has to be negative. So negative cos 50 degrees. Okay, now have a look at this plus minus here. We're going to have to deal with that. So that we can rewrite. Cos 70, cos 40, minus sine 70, cos 50. Okay, now let's have another look. We have got 70, 70, we're working towards this compound angle thing. 40, 50, that's a problem. 50 and 40 are actually not the same. Okay, but what is 50 plus 40? That's going to be 90. So we could actually change one of these to be a co-function. So I'm allowed to change cos of 50 and make it sine of 40. And then hopefully that, because then the angles will be the same, hopefully that will be one of my formulae that I'm looking for. So cos 70, cos 40 minus sine 70. And then we can do the whole cofunction just in one step if you're comfortable with that. Sine 40. So what you're essentially doing is you're making a step here where you say, I'm going to rewrite this as cos 90 minus 40 degrees, and then you co-function it there, and it becomes sine of 40. Now, having a look at this formula sheet, I can see I've got cos, cos, sine, sine, and a minus. So cos, cos, sine, sine, and a minus is cos A plus B. Let's see what that becomes. Cos 70 plus 40. Right, and we can then rewrite that. Those are like terms. So 70 plus 40 is 110 degrees. And then that is a big angle. So we're going to go back to our cast rule. And we're going to say, right, where is 110 degrees? It sits somewhere here between 90 and 180. So we're going to rewrite that as a second quadrant thing. So cos of 180 minus 70 gives us that 110 degrees there. And then cos in the second quadrant, sine is positive, so cos is negative. This then simplifies to minus cos of 70 degrees. And there we have simplified from something that was quite complex using our cofunctions and our compound angles all the way down to minus cos of 70 degrees.